11.1 goes over exponential functions and their applications. If we look at the first set of examples, we're looking at these exponential functions and told to just evaluate when x is a given term. If we look at example 1, we're told that f of x is equal to 2 to the power of x, g of x is equal to 1/4 to the power of 1 minus x, and h of x is equal to negative 3 to the power of x. For example A, we're finding f of 3/2, which means we're just going to turn that x into 3/2 in that 2 to the power of x. So we have that f of x is equal to 2 to the power of x. So we find f of 3/2. We're going to have 2 to the power of 3/2. Now, if you remember from a while ago, that power is a fraction. The numerator is going to stay as the power. The denominator is your index. So that is going to give us f of 3/2 is equal to the square root of 2 cubed. We're not going to simplify the square root of 2. However, we are going to raise it to that third power. So this is the same exact thing as saying f of 3/2 is equal to the square root of 2 times the square root of 2 times the square root of 2. When the radical is the same, or the index is the same, we can multiply what's underneath them, and it's just going to give us f of 3/2 is equal to the square root of 2 times 2 times 2. Our index is an invisible 2, so we're grouping up sets of 2. Two twos pair up, so you're going to bring one of those out. So we're just going to have f of 3/2 is equal to 2 square root 2. And because that radical is not in the denominator of a fraction, we can leave it just like you have it. For example B, we have f of negative 3. So again, we're going to use f of x is equal to 2 to the power of x. In this case, our x is going to be negative 3, so f of negative 3 is equal to 2 to the power of negative 3. In order to turn that power into a positive, take the reciprocal of the 2. So it's going to be f of negative 3 is equal to 1/2 to the third power. That 1/2 to the third power, we're just going to do the 1/2 times 1/2 times 1/2. 2 times 2 times 2 is 8, so f of negative 3 is equal to 1/8. For example C, we're doing g of 3. So we said that g of x is equal to 1/4 to the power of 1 minus x. So this is going to just give us g of 3 is equal to 1/4 to the power of 1 minus 3. 1 minus 3 is negative 2. So g of 3 is equal to 1/4 to the power of negative 2. We turn that negative 2 into a positive 2, take the reciprocal of the 1/4. So that's g of 3 is equal to 4 to the second power. 4 squared is 16, so g of 3 is 16. For example D, we have h of 2. So we said prior that h of x is negative 3 to the power of x. If you want to rewrite this so that way it makes it a little bit easier for you, this is the same exact thing as saying take the opposite of 3 to the power of x. That negative is not necessarily attached to the 3 because the parentheses is not around the negative 3. So that negative is literally telling you to take the opposite of whatever 3 to the power of x is. If we plug in that 2 for x and find h of 2, it's going to be the opposite of 3 squared. 3 squared is 9. So h of 2 is going to be the opposite of 9. The opposite of 9 is negative 9. So h of 2 is equal to negative 9. For our next examples, we're doing the same exact thing. So we have f of x is equal to 10 to the power of x, g of x is equal to e to the power of x. For these, you're going to need a calculator in order to work with that e. If we look at example A, we have f of 3. So f of x is equal to 10 to the power of x, so that's 10 to the power of 3 if we're finding f of 3. That 3 tells you how many zeros you have in your answer, so f of 3 is just 1,000. For example B, we're doing f of 1.51. So again, we're going to use f of x, which is 10 to the power of x. If we plug in that 1.51 for x, we're going to have 10 to the power of 1.51. We use our calculator, and we get that f of 1.51 is equal to 32.4 decimal places. That would be 3594. Again, we're just using our calculator to find that number. For example C, we have g of 0. For this one, we're going to be working with g of x, which is e to the power of x. Now, e is the inverse of that ln button on the calculator. So if you have a two-function calculator, you are just going to use that second function and type or hit that ln button in order to get that e to the power of x. So if we plug in that 0, we shouldn't need to use our calculator for this because it's e to the power of 0, and anything raised to the power of 0 is 1. So g of 0 is equal to 1. For example D, we're finding g of 2. So again, we're going to use that g of x, which is e to the power of x. If we plug in the 2 for x, we have e to the power of 2. We use our calculator. We hit that second button, then that ln button. Type in that 2, and we get 7.389056099. If we're rounding to the nearest or the fourth decimal place, we have 7.3891. So for example 3, we are given the function rule f of x is equal to 2 to the power of x. With these, we're given values for x. We're just going to have to plug them in and simplify. So for the first x value, we have negative 2. So we are going to plug that in and have 2 to the power of negative 2. Remember that negative 2 is going to turn that into a 1/2 to the second power, which is 1/4. So this is the ordered pair, negative 2, 1/4. For the negative 1, that's 2 to the power of negative 1, which is just 1/2. And that's the ordered pair, negative 1, 1/2. Then we have 0. Anything to the power of 0 is 1. So that gives us 0, 1. Next we have 1, so 2 to the first power is 2. And that's the ordered pair, 1, 2. Next we have 2, so 2 squared is 4, and that gives us 2, 4. And then we have 2 cubed, which is 8, and that's the ordered pair, 3, 8. So if we go to graph these ordered pairs on our coordinate plane, we're just going to have negative 2, 1/4, which is going to be about here, then negative 1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. From here, we just have to draw our line through these points. You'll realize that that line is going to get very, very, very close to that x-axis, but not go through it, and go up as it moves to the right. For our next example, B, we have g of x is equal to 3 to the power of x. So for this one, we're given x values of negative 2, negative 1, 0, 1, 2, and 3. We're just going to plug those in. So the first one we're going to have is 3 to the power of negative 2, then 3 to the negative first power, 3 to the power of 0, 3 to the first, 3 to the second, and 3 to the third power. That 3 to the power of negative 2, take the reciprocal of that 3, that's 1/3 to the second power is 1/9. Then 3 to the negative first power is 1/3. Anything to the power of 0 is 1. 3 to the first is 3. 3 squared is 9. And 3 cubed is 27. So this gives us the ordered pairs negative 2, 1/9, negative 1, 1/3, 0, 1, 1, 3, 2, 9, and 3, 27. So again, from here we just plot those points, draw our line through them. So negative 2, 1/9, again, is very close to that x-axis. Then negative 1, 1/3, 0, 1, 1, 3, 2, 9, and 327 is not going to fit on that coordinate plane. So we're just going to use these points that we have, draw our line through them. We get that curved line. We designate that it does not go through that x-axis because there's actually something called an asymptote. An asymptote is an invisible line where that drawn line on the coordinate plane does not cross over. So again, it gets really, really close to that x-axis and goes up as it moves to the right. For our next example, we have f of x is equal to 1/2 to the power of x. Again, our x values that we're working with are from negative 2 to 3. So we're going to start with that 1/2 to the power of negative 2, then 1/2 to the power of negative 1, 1/2 to the power of 0, 1/2 to the first power, to the second power, and to the third power. For the negative 2 as your exponent, we're going to take the reciprocal of that 1/2, which is 2, and then raise it to the second power, which is 4. The 1/2 to the negative first is just 2. The 1/2 to the power of 0 is 1. 1/2 to the first is 1/2. 1/2 to the second is 1/4. And 1/2 to the third power is 1/8. So this gives us our ordered pairs of negative 2, 4, negative 1, 2, 0, 1, 1, 1/2, 2, 1/4, and 3, 1/8. So again, we just plot those points. We have negative 2, 4, then negative 1, 2, 0, 1, 1, 1/2, 2, 1/4, 3, 1/8. So this one, you see, when we do this, it's going to go up as we go to the left. And again, it still does not cross over that x-axis. And for example B, we have g of x is equal to 4 to the power of negative x. For this one, for that negative 2, we're going to have 4 to the power of negative, or the opposite of negative 2, 4 to the power of the opposite of negative 1, 4 to the power of the opposite of 0, 4 to the power of the opposite of 1, 4 to the power of the opposite of 2, and 4 to the power of the opposite of 3. The opposite of 2 is positive 2, so 4 squared is 16. The opposite of 1 is 1, the opposite of negative 1 is 1, so 4 to the first power is 4. 0 is neither positive nor negative, so 4 to the power of 0 is 1. 4 to the negative 1 power is 1/4. 4 to the negative second power is 1/16. And 4 to the negative third power is 1/64. So our ordered pairs that we're working with are negative 2, 16, negative 1, 4, 0, 1, 1, 1/4, 2, 1/16, and 3, 1/64. So to plot these, that negative 2, 16 is not going to fit on our coordinate plane. So we'll start with that negative 1, 4, and that 0, 1, 1, 1/4, 2, 1/16, and 3, 1/64. Again, it's going to get really, really close to that x-axis and go up as it goes to the left. For our next set of problems, we're going to be just solving these equations. For each of these equations, our variable is in the exponent. When this happens, you want to make sure that each side of that equal sign has the same base. Once each side has the same base, you can actually cancel out the base and just work with the exponent. So if we look at example 5a, we have 2 to the power of x minus 1 is equal to 8. That 8 can be changed into 2 to the power of 3. So we'll start this just by rewriting it. So that way we have 2 to the power of x minus 1 is equal to 2 to the power of 3. Now that both of your bases are the same, they can cancel each other out, and you'll just have to work with the exponent. So you're working with x minus 1 is equal to 3. Move that 1 over by adding it to both sides. And you have that x is equal to 4. For example B, we have 9 to the power of the absolute value of x is equal to 3. Once again, we need the same base on both sides. This 9 has to be turned into 3 to the power of something. So we're going to have 3 to the second power times the absolute value of x is equal to 3. That 3 that's by itself on the right-hand side does not have a power, so we're going to write it in as a 1. From here, again, your bases are the same, so they can cancel each other out, and we'll just work with 2 times the absolute value of x is equal to 1. We're going to divide each side by the 2 to get that absolute value of x by itself. So we have the absolute value of x is equal to 1/2. In order to get x, not the absolute value of x, we're going to get rid of those absolute value bars and write 2 equations, one that's equal to the opposite of our answer and one that's equal to our answer. So we're going to have x is equal to negative 1/2, as well as x is equal to the 1/2. Remember, with these, absolute value can never be negative. So whenever you take the absolute value of something, you will always get a positive answer. If by any chance you are left with the absolute value of x is equal to a negative number, it would automatically just be no solution. For our next example, we have 1/8 is equal to 4 to the power of x. Well, we know that 4 is 2 to the power of 2, so this is going to be 2 squared times the power of x. That 1/8, though, has to turn into 2 to the power of something. So if that 2 is raised to a negative, that's what gives us that 1/2. 2 to the third power is 8, so this is just 2 to the negative 3 is equal to 2 times to the power of 2 times x. So now that our bases are the same, they can cancel out, and we're just going to work with the negative 3 is equal to 2x. We're going to get x by itself by dividing each side by the 2. And we have that x is equal to negative 3/2. For the last section of our notes, we're going to let f of x equal 2 to the power of x and g of x equal 1/2 to the power of 1 minus x. For example A, we're going to find when f of x is equal to 32. So we're solving for x. We're told that f of x is equal to 32, so we'll use the f of x is equal to 2 to the power of x, and we'll plug in 32 for the f of x. So f of x, let's do it like this. F of x is the 2x, or to the power of x, and that's equal to f of x, which is also 32. So turn the 32 into 2 to the power of something. We have 2 to the power of x is equal to 2 to the 5th power. Your bases are the same, cancel them out, and you just have that x is equal to 5. For example B, we have g of x is equal to 8. Well, g of x is that 1/2, oops, did it again, 1/2 to the power of 1 minus x, and that x, or that g of x is equal to 8. So this at 1/2 to the power of 1 minus x is equal to 8. 8 is the same exact thing as 2 to the third power, and 1/2 is the same thing as 2 to the negative first power. If we multiply the power of negative 1 to that 1 minus x, we would just have one specific or one expression for that power. We have two bases that are the same, so they cancel out, and we're just going to work with the negative 1 times 1 minus x is equal to 3. You could distribute this negative 1 in. You would just be working with negative 1 plus x is equal to 3. You can add the 1 to both sides, and you get that x is equal to 4.